So in last lecture we discussed rotate instruction. That is one of the class of logical instruction, and today we will see shift instruction. So there are again four categories of shift instruction. These are S, H, L. This is shift left logical. Then SAL, shift left arithmetic. This. Then SHR, shift right logical, and SAR, shift right arithmetic. So A in this instruction, in this opcode indicates this is arithmetic. So arithmetic shifting shift right side, R indicate right side arithmetic. Here shift left side, L is indicate left side arithmetic. And in SH this is logical shift. SH is logical shift. L means logical shift left and R means logical shift right. Now just like rotate instruction, it also has two operand, one destination and count. For example, for SHL instruction, I will write destination, comma, count. So it is exactly, operand is exactly same as our rotate instruction. So destination can be a 8-bit or 16-bit register, or the content of the memory can also be used. And in case of count, if we are shifting the number by 1, then we write 1 in count position. And if we are shifting the number more than once, then total number of times how we want to shift, that value we load in CL register, and that we will place at this position. So with one 8-bit number, we will see what are the various operations for these instructions. Suppose in some AL register we are having some 8-bit number 74H, this, and we have stored that number in AL register 74H, and after this we have written instruction SHL AL, 01H. So now we want to shift the value of AL, we want to rotate, shift the value of AL left side logically. So the meaning of this is, the value of AL is 74, I will write in binary. It is 0, 1, 1, 1. This 7 and 4. 0, 1, 0, 0. This is the value of AL. And this is the carry flag. So when we are shifting this number towards left side, then you just see this 0 will go out, right? And it will be stored in carry flag. So this 0 will come in carry flag. And the remaining 7 bits will be like this. So whatever is the MSB, that I will remove, because it will be simply stored in carry flag. Now what is the next bit position? That will become MSB. 1, 2, 3, 4, 5, 6, 7. And now this is the vacant bit position. So now this vacant bit position will be filled by 0. Right? Whatever was the MSB or whatever was the LSB, it does not matter in case of shift operation. It will always be filled by 0. So here we will place 0. So this is the answer. In carry flag, it was 0. So in case of S shift left logical, in case of shift left logical, the number will be shifted left side and the vacant bit position at the right side will be filled by 0. Right? We will take another example. Suppose we take a value 34H. Now 34 we write in binary. 3 means 8, 4, 2, 1. This is 3 and 4, 8, 4, 2, 1. This is a 8-bit number. And this is our carry flag. So now when we shift this number by using SHL instruction, shift left logical, right? So what will happen? This 0 will come to carry flag position. This 0 will come at this position. This will come here. Each bit will be shifted left side by 1 bit position. This is the vacant position. So vacant position will be filled by 0. If we now this is our new result. Now again if we shift this once left side by logical by SHL instruction, then again this 0 will go to the carry flag, it will remain 0. Now this one will come at this position, this here, this here. This bit position is vacant. Again fill it by 0, because whenever we are using this SHL shift left logical, number is shifted left side, so there is a vacant position at the right side and the vacant position will be filled by 0. Now similar to SHL, there is SHR instruction. SHR, shift right logical. So in this case, whatever is the number, it has to be shifted right side. Means LSB bit will go out. So LSB bit will go out and it will be stored in carry flag. And all the numbers will be shifted 1 bit right side. So there will be a vacant bit position at leftmost bit position, right? That is at MSB, and that will be filled by 0. So we will take one example. Same example we can take. Move AL, 74, and in place of SHL, now we will use SHR. So 74 is the value of AL. So AL is equal to 74. This will be 0, 1, 1, 1, 0, 1, 0, 0. This is 74, right? So now this number has to be shifted right side logically. So as I told you, the LSB bit position will go to carry flag. This will go to carry flag, and all the numbers will be shifted right side by 1 bit position. This 0 will come at LSB position. This one will be shifted right side by 1 bit. This 0 here. This one will come at this position. This one will come at this position. This one will come at this position, and this 0 will come at this position, and this is the vacancy. Right? So all the numbers are shifted right side. So total numbers are 1, 2, 3, 4, 5, 6, 7, and at the MSB we are having vacancy. So this vacancy will be filled by 0. It will be filled by 0. So this is the answer. 0, 0, 1, 1, 1, 0, 1, 0, and carry flag is 0. So in case of SHL and SHR, that is shift left logical and shift right logical, numbers will be shifted and the vacant bit position will always be filled by 0. Now SAL and SHL both are same. There is no difference. There is two names for same operation, right? Always remember, SHL is same as SAL, right? So if you use SHLAL, 01, or you use SHL, AL, 01, both will give you same result. It is same. So don't bother about this. Now only thing is we have to see this. Shift right arithmetic. Now in case of shift right arithmetic, numbers will be shifted right side. Right? Whatever is the number. So numbers will be shifted right side. So there will be vacancy at MSB bit position, right? At the most significant bit position. So those vacancies will be filled by the sign bit of the number. Means the MSB of the number. So I will tell you. We will take, say example, for this example we can take. Move AL, 74H, then SAR AL, 01. So value of AL is 74H. 0, 1, 1, 1. 0, 1, 0, 0. This is the value, right? This is your MSB, and this is our carry flag. This is our MSB. So now, in case of SAR instruction, since here at the count place we are having 1, so it will shift the number right side arithmetic. So here, this 0 will go to carry flag. So in carry flag, this 0 will be shifted. And all the numbers will be shifted right side. You note down the MSB value somewhere. MSB bit position is 0. Right? You note down somewhere. What is the sign bit? Sign bit means MSB bit indicates the sign bit. If this bit is 0, indicates number is positive. If this bit is 1, it indicates number is negative. So note down the sign bit somewhere. MSB bit is 0. And this 0 is shifted here and all the numbers will be shifted right side. So when it will be shifted right side, so this 0 will come at this place. This one here, this 0 here, this one here, this one here, this one here, and this 0 will come here. Okay, this 0 will come here. And there is a vacancy at the MSB bit position. So at the MSB bit position, we have to fill here the sign bit of that number. So what was the sign bit of the number? 0. So it will fill, we will fill here 0. We will fill. Right? We will take another example. If we are having 80H in AL register, let us see what will happen now. Carry flag, let us assume it is 0 previously. AL is 80H. 80 means 1, 0, 0, 0, 0, 0, 0, 0. and we are using instruction SAR. So what is the MSB bit? We will now note down somewhere. It is 1. Now this 0 bit will go to carry flag. Already carry flag was 0, so there will be no change. So carry flag will remain same. This 0 will come here. All the bits will be now shifted right side. So this will come at this position. This 0 here, this 0 here, this 0 here, this 0 here, this 0 here. This one will come at this position. There is a vacancy at this position. So MSB vacancy will be filled by the most significant bit of original number. So original number MSB was 1. So here you will get 1. So in this way, and if now this is our result. Carry flag 0. Now if again you shift this number by SAR instruction once again, then what will happen? Again this 0 will go to carry flag. All these numbers will be shifted right. So 0 0 0 0 means 0 0 0 0 to here 0 1 1 0 1 1. There is a vacancy. So now since we were shifting this number this time, so in this number the MSB bit was 1. So again this bracket with position will be filled by that one. So in this way we will use SAR. So these are arithmetic and this is logical instruction, in which rotate instruction and shift instruction are the part of this logical instruction.